Hi guys again. Again, this is today is March 31st, 2020, and this is our math video for today. If you recall, we've been working on fractions of a set, and a lot of you have sent me in your pictures of your exit tickets, which shows that you're understanding the concept of a fraction of a set and really understanding fractions that are equivalent to one another. So I'm going to start off by sharing our learning intentions as we always do at the beginning of a lesson. So 1 second as I pull that up. And let's go into present mode. So our learning intention for today. Today we are going to continue our exploration with the egg-Carton fraction model in order to investigate how we can represent a fraction of a set in many ways. Success criteria: I can represent a fraction of a set in multiple ways and therefore explain fractions that are equivalent. And so with our success criteria today, I'm going to ask you guys to do a little bit of writing to explain your thinking. And your language intention: I use words from our fractions anchor charts, and social intention as always, I do the work even when no one is looking. So we're going to go into our fractions anchor chart. Remember, if I say the word, you say the word at home. If I do the gesture, you do the gesture as well. So say it with me: numerator, denominator, benchmark fraction 1/2, part, whole, partition, equal parts, equivalent, greater than, less than, equal to, a bar model, a pi model, number line, unit fraction, and fractions greater than a whole. And we have our different models and strategies that we've talked about and we've utilized in class, like the pi model, the bar model, the number line, and our fraction claim. So I'm going to read the claims to you one more time. They're kind of grainy and hard to read, but I'm going to go back to fraction claim number 1. When the numerator is the same, such as 1/4 and 1/2, you look to the denominator. The smaller the denominator, the larger the piece out of the whole. So that's fraction claim number 1. We've talked about that in class before. Claim number 2, when the denominator is the same, you look at the numerator. The larger the numerator, the more pieces out of the whole. For instance, if I had a chocolate bar and I said, hey, I'm going to have 1/4 of it and you're going to have 3/4 of it, you're obviously getting more out of that chocolate bar because you're getting 3 pieces out of the 4 pieces, whereas I'd be getting only 1 piece out of the 4 pieces. Claim number 3, when the numerator and the denominator are the same, the fraction is equivalent to 1 whole. So we see here 4/4. If I said, hey, I ate 4/4 of the chocolate bar, it's the same as me saying I ate the whole chocolate bar. So when we see that the numerator and the denominator are the same number, we know that that's equivalent to 1 whole. And claim number 4 has to do with fractions greater than a whole. When the numerator is greater than the denominator, the fraction is greater than 1 whole. So for instance, 5/4 is greater than a whole because imagine I have 2 Kit Kat bars. They're both partitioned or cut into fourths, and I ate 4 pieces out of the first one, which means 1 whole, and then another piece from the other one, which means 1 1/4, or 5/4, because they're cut, right? Each one is cut into 4 pieces, and I ate 5 pieces out of each bar, which is partitioned or cut into fourths. So that's your claim number 4. We're actually going to start with, this was actually our exit ticket from yesterday, but I turned it into a do now as a way to review. So I had asked you guys to copy this egg carton in your math notebook and shade in 1/6 of the eggs, the color red. There are many ways you can represent 1/6, and then I asked you to send it to me. Send it to my phone number. You don't have to do that right now because that was your exit ticket from yesterday, but I do want you to take out your math notebook because even if you did send it to me, let's just review it and make sure that you understood how to represent, or how many ways can we represent 1/6. So watch as I write on here. So I'm looking, I'm looking at this egg carton and it's asking me to represent 1/6. It's asking me to represent 1/6. But here's the thing though, when I look at the egg carton, I see 12 spots, right? Whenever you open an egg carton, there's 12 spots. It's a dozen. But I know I have to represent it into six parts in total, right? That's how I'm going to partition the whole. So I'm wondering if I can use some division to figure out how I'm going to draw out 1/6 to begin with. So if I have 12 egg carton spots in my egg carton, and then I need to have 6, I'm going to divide 12 divided by 6. So I'm going to write that down so I don't forget. I'm going to write 12 divided by 6. And if you're like, wait a minute, Ms. Maldonado, I don't know my division facts yet. Well, you know your multiplication facts. So you're going to say 6 times what is going to give me 12. And if you're like, wait a minute, I know this is easy. You said 2, you're right? 6 times 2 is 12. So I know the way that I'm going to divide it is that every part on my egg carton is going to have 2. So I'm going to draw 6 lines. So watch as I do it. I'm going to make this line a little bit thicker so you guys can see it. Where's the thick line? Looking for the thick line right now. Can't see it. I forgot where I have it. 1 second. Oh, here we go. Okay, so 6 lines. So here's my first line, my second line, my third line, my fourth line, my fifth line. But, right, it's 6. If you look, 1, 2, 3, 4, 5, 6, right? Now it's divided. I've divided the 12 places in the egg carton. I divided it by 6 because we're partitioning into 6. And so each part, right, has 2. And now I have to represent 1/6. If I said I ate 1/6 from the egg carton this morning, I'm going to grab a different marker so I can show you, and maybe a different color. Let's do pink. If I ate 1/6, I ate this amount. So I'm going to just highlight it. Yeah, do you guys see that? If I didn't have this line down the middle, it'd be even easier to see that that represents 1/6 out of this fraction of a set. Out of 12 eggs, this is what 1/6 looks like. And so now I know that 1/6 can be represented as 2 eggs. So now I know that from this point forward, if I go down, I just have to highlight 2 eggs to represent 1/6 from the egg carton. So you might have done this one, that would still be 1/6 because it's 2 eggs out of the 12. That represents 1/6. I could have done these 2 in the middle, or these 2 right here. I could have done 1 over here, 1 over here. As long as you represented 1/6, either like this or any of these other ways that you're seeing, or as long as you highlighted 2 eggs out of the 12, you definitely are representing 1/6 of your egg carton model, okay? If you have any questions and you're like, this is still confusing, Ms. Maldonado, make sure you send a message to me and I can try to see if I can call you personally to kind of go over it with you a little bit more, Ms. Alonso, Ms. Delgado. But we're gonna continue with the next slide. So let me just clear our drawings and let me click the mouse. And here we go. So I said the claims at the beginning because we've talked about the claims so much this year and we're going back into fractions. And so we're gonna just do some comparison work right now. We're gonna compare these fractions, and the question is, or what are we doing, is which symbol would make this comparison true? Greater than symbol, less than symbol, or equal to symbol. So I'm gonna ask you to open up your math notebook to the next little clean section. And I want you to write these 4 comparisons down. You can use a bar model, you can use a number line, you can do the pie model if you know that you can get your equal parts down right. You can use your claims if you need to go back in your math notebook to find the claims, or if you need to go back in the video to go to the claims where I was reading them, do that. But I'm going to give you, I don't know, let's do 5 minutes trying to compare these fractions. And so when you're ready, you're going to unpause me. All right, hopefully you wrote down every comparison and you're able to kind of think through which fraction is greater. Is it greater than, less than, or equal to, right? So I'm gonna grab a different color. Let's do blue this time. And let's do this one, and yep, I got it. Okay, so the first fraction that we're comparing is 1/6 and 1/3. If I go back to one of my claims at the beginning of the video, I know that if the numerator is the same, I have to look to the denominator. And the smaller the denominator, if the numerators are the same, the larger the piece. And so I'm looking, I have 1/6 and I have 1/3. So I'm thinking 1/3 is going to be greater than 1/6, or 1/6 is less than 1/3. If you are able to say that, give yourself a big check mark. So 1/6 is less than 1/3. Let's do the next one. We have 7/8 and we have 4/8. So which fraction is greater than, less than, or equal to? Well, if I look at 4/8, I know 4/8 is the same as 1/2, and 7/8 is almost close, right? It's only one piece away, or one part away from being a whole, right? Do you guys see that? Because I just need to make it 8/8 to make it a whole. So if I think of maybe a number line, right? I'm gonna draw it out. That's a really ugly number line. Sorry about that, guys. If this is 0, right, and this is 1 whole, I know halfway down the middle, that's going to be a half, or 4/8. And then 7/8 is going to be somewhere where? Is it going to be closer to the 0, over here, or over here? Yep, if you said closer to the 1, you're right, because it's only one piece away from being a whole. So I'm going to say 7/8 is greater than 4/8. All right, our third fraction that we're comparing 4/8 and 3/6. I want you to look at the relationship between the numerator of each fraction and the denominator. Look at the relationship between the numerator and the denominator. What do you notice? Pause the video just to think to yourself, what do you notice about the relationship between the numerator and the denominator? If you said, hey, 4 is half of 8 and 3 is half of 6, you're right, which means, or therefore, 4/8 has to be equivalent to 3/6. So if you did say that, give yourself a big check mark. 4/8 is the same as 3/6. And lastly, we're going to compare 2/3 and 4/6. I'm going to write it out this way so you guys can see the fractions a little bit easier side by side, but I have 2/3 and 4/6. And we don't have our claim up for this one. I think I'm going to add it for tomorrow. This one's a little bit more difficult because if you notice, the numerators are not the same when comparing them side by side, and the denominators are not the same. So we have a numerators that are different and denominators that are different. But you can look at the relationship going from this way. So I'm going to use a different color just to show you. So this is in the numerator, it's 2 over here, and the numerator here is 4. And then our denominator over here is 3, and our denominator over here is 6. I want you to think about, well, what do you notice between the relationship between the numerators across and the denominators across? Pause me to think. What do you notice about that relationship? Well, you're back. If you said, oh, it seems like it's just doubling going this way, you're right. If you said it seems like 2/3 has just been doubled, you're absolutely right. It has been doubled. So 2/3, it seems like they multiplied the numerator 2. by 2, and that gave us a numerator of 4, and then they multiplied, they doubled the 3, and it gave us a 6, which must mean that 2/3 is the same as 4/6. Even though the fractions are different, it's kind of like what we're doing with the egg cartons. The fractions look different, right? Or it seems like the representations look different, but it really means that it's the same, right? It's equivalent. So again, if you're having trouble with this and you're like, Miss Maldonado, I'm really having a hard time with fractions again, remember that you can message me separately so that we can talk a little bit more about it. I'm going to clear all drawings, and then we're going to go back into our learning intention for today, which was looking at this egg carton model. And we're going to really just go deeper and deeper with fractions. I want you to pause the video in a second. I want you up at the top of your page, a whole clean page for this. How many ways can you represent 2/3 with the egg carton fraction model? Which comparison statement can we make? This, I told you earlier, we're going to do some writing. We definitely are. And aside from writing the top and the question and this part, I want you to copy down these 4 egg carton models because we're going to utilize them to represent 2/3. So do that now and then unpause me when you're ready. All right, so let's start. Our fraction is 2/3. Oops. Our fraction is 2/3. I'm going to grab another color. I know I need to compare. Let's get our color going. I know I'm going to represent 2/3. I'm just going to write it on the side. Okay, but wait a minute. 2/3 of this egg carton, and there's 12 eggs. And I know that I need to partition into 3 parts to really represent 2/3. So I have to divide these 12 eggs into 3 parts, into 3 total parts, because that's my denominator. So 12 divided by 3, and if I don't know what 12 divided by 3, I can use my connection between division and multiplication. Remember, we talked about how those are interconnected, and I could say, well, 3 times n equals 12. 3 groups of equals 12. 3 groups of 4. So n equals 4. So now I know that I have to partition or draw out and make sure I have 4 parts in this egg carton. So let me see. 12 divided by 4. So in each part, I'm going to have 4 eggs. And if you notice, right, if I were to delete this line down the middle, it would look like thirds, right? Now I need to make sure I have 2/3. So imagine I don't have this line down the middle, right? I'm going to represent, or I'm going to shade in 2/3 of the eggs, right? I'm going to pretend I ate, or my family ate 2/3 of eggs this morning. Let me grab a different color. Shade it in. Where is it? 1 second, guys, as I'm trying to figure this out. Okay, so 2/3. Well, this would be 1/3, right? It looks like 1/3. And this would be 2/3 of my egg carton. So how many, if I ate 2/3 of my egg carton, how many eggs did I make this morning? Show me with your hands. 3, 2, 1, and go. Yeah, 8 eggs. If you ate 2/3 of your egg carton, you ate 8 eggs. Now that I know that 2/3 is the same as 8 eggs, now I can shade in, or I can represent 2/3 in multiple ways, in many ways. I just have to remember that I have to shade in 8 eggs. So I might do it like this. I might do, these are 4 eggs. Maybe I'm going to represent 2/3 this way. And it would still be the same, right? Let me do it a different way. Maybe I represent 2/3. Maybe I do it like this. I'm going to shade in 4 over here on this side. and then another 4 over here. This would still be 2/3 of my egg carton because I know 2/3 of my egg carton is the same as 8 eggs. I could also maybe do it like this. Maybe I'm gonna just shade it in like this. That's 4 eggs, 6 eggs, 7 eggs, 8 eggs. Either if you had a different, or you're thinking of a different way to represent 2/3, go for it. Just remember 2/3 in our egg carton model is the same as 8 eggs. So lastly, my friends, what we're going to do, and if you need to pause right now to finish doing this, go for it, pause it, and then just unpause me. But I'm about to clear. The last thing I'm gonna ask you to do is an exit ticket. And I am gonna ask you to write it down in your math notebook and send me a picture to Ms. Maldonado's cell phone number, or somebody, Ms. Alonso, Ms. Delgado's phone number, to show that you're practicing comparing fractions or finding fractions on a number line. This is review. So hopefully this will be like, oh, this is easy peasy. But it says to complete the missing information below by writing in the fraction number or sketching the given fraction on a number line. They show you how to write out 1/3, and they took the denominator. They know that they had to divide this, partition this line into 3 whole parts. Where are my 3 parts? Well, here, this is 1 part, 2nd part, 3rd part, and then with the arrow, they're representing, well, this would be 1/3. And they forgot to label it. I would want you to label it down below. Same, you're gonna label 1/4 on the number line, and then here, this is kind of a trick one. What fraction would this be if they represented it this way? Make sure you send me a picture. Again, if you have any questions, let us know. See you in the next video, my friends. Hopefully you're enjoying these math